putting girl jewelry on a boy dog. He's got enough self-esteem issues as a chihuahua.
That's his bling.
What do you mean it's a CK12?
The website.
Shades Fingers.
Alright, so we live in, this is chapter 39 of the Milky Way. We live in a galaxy called the Milky Way. It is shaped like a frisbee, kind of, or a UFO. It's a disk of stars and gas, dust, and even some stuff called dark matter that we don't really know what it is. And it's huge. So it's kind of shaped like this. If you look at it from the side. That was a good drawing. I'm really good. So there's a central bulge, and then it goes kind of thins out on the sides, and this whole thing is spinning. And if you looked at it from top down, it would just look like a disc. And we're located kind of out here on the edge, not on the edge, but in this kind of this part of the disc. If you go outside and you look up this way or down that way, you're not looking through as many stars as if you look that way or that way. If you look along the edge of the disk, you can see a higher concentration of light and gas and dust. And that's what this is. Sam and I saw this last night. It wasn't as nice as this. This is kind of an enhanced photo. But if you go outside and you look up on a clear night, you'll see a line of gas, looks like gas and dust and light going across the sky. And that's the plane of our Milky Way. So when you look through this way, you're looking through a bunch of stars and dust, and it's thicker there, and there's more stuff there. The ancients thought it was milk in the sky, so they called it the Milky Way. Why not? It's milk in the sky. Of course, they didn't have a lot of time to worry about that kind of thing, but that's how we get the Milky Way. So, hopefully tomorrow night we can go out and look at that. Now, here's a top view looking down. And of course, we've never actually taken this picture because we'd have to get out of our galaxy to see it. And we've never even been past out of our solar system. To get out of the galaxy would take hundreds of millions of years.
Is that like a painting?
Yeah, this is an artist's conceptual drawing. But we see a lot of other galaxies in space through our telescopes. So we can get an idea of what our galaxy probably looks like by looking at other galaxies. Yeah.
How do we know that we're there in the galaxy?
That's a great question. They can measure the distances to other stars that we can see. And once they figure out the distances to all these other stars, they can put them in a computer and kind of draw a picture of our galaxy based on that. But it took, just figuring out where we were in our galaxy took hundreds of years of observations. It wasn't an easy thing to do. At first, we didn't even know we were in a galaxy. And then when we started seeing these other galaxies, and then especially when the telescopes got bigger, we started thinking we might be in a galaxy. Yeah.
In the middle, is that the supermassive black hole? That white
The supermassive black hole will be at the very center. You can't see it.
What's all that bright?
In this picture, this bright is a lot of stars. So there's less stars toward the outside, and there's more stars toward the inside. And because there's more stars there, it's a lot brighter. There's a lot of stars in the galaxy. We think our galaxy has anywhere from 200 to 400 billion stars. Our sun is one of them. And the average distance between stars is a few light years. So this whole thing is an enormous size. Giant. And we're just one little dot. Our dot is so small that you couldn't even see it. We're just a little dot.
This is only one galaxy.
This is our one galaxy. The Milky Way is what we call it. We think there's maybe...
Wait, can we see into the galaxies?
We can see other galaxies from with our telescopes.
Can you see into them?
Is it just the ones out from that like edge, or could we see across, like through all that? You know what I'm saying? Like through the bunch of stars that are in the middle. If we see galaxies on the
Can we
edge.
look through this and see stuff on the other side?
Yeah, that's what
Very difficult to. It's a lot of traffic there to try to see through it. Radio telescopes can see through it because radio waves go through most stuff. Just like they go through walls and you can pick up radio signals, radio waves go through dust and gas, and our radio telescopes can kind of see through all this junk to the other side. But really, the other side, if looking directly through from where we are, trying to look directly this way, is difficult. But we can easily see this way and that 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 way. We just can't really see that way very well.
How many galaxies do they think there are?
So far, we've seen about 400 or 500 billion other galaxies out there.
And how many solar systems are in a galaxy?
Well, each galaxy has about 200 to 400 billion stars. We think each star has planets around it. So that's each star is a solar system.
How can people not think there's other life on planets?
Pretty sure.
Do people not think there's other life on planets?
Yeah.
Pretty sure.
Really?
Wow, there's like...
Who
there
does?
has to be.
We haven't proved it. We don't know that there is, but
Crazy.
I mean,
I would think there'd likely be.
It's out there.
Pretty sure.
There's probably a ton just in that one galaxy.
Like even in our galaxy, there could be. I feel like.
Yeah.
Or would we know that already? Or would we know
Even in our galaxy, there could be what?
Like, don't you think even in our galaxy there could be other life? Or have we seen all of our galaxy?
No, we haven't even seen nearly all of our galaxy.
They could just
We
be-
haven't even seen the closest stars,
Wow.
other than through a telescope. We hadn't seen what's on the planets around them. We know that there's planets there, but we can't see the planets, so we don't know if there's anything on them or not. So, yeah, we're just starting to investigate that. The last chapter that we'll do is, what are the odds that there's life on other planets? That's the last chapter. And we'll talk
Really,
about
really
that.
high.
There's actually scientific
I'm
work
so
on it.
ready.
An equation called the Drake equation that gives you the possibility that there's life on other planets.
I want to be invaded.
So you need to know all the parts of our galaxy. The center, the central bulge is called the galactic bulge. That's this. This is the galactic bulge, and that's where there's a high concentration of stars and gas and dust and heat and light. There's just a lot of stuff right here. And this is because our galaxy formed from a huge bunch of gas and dust that got pulled in by gravity and started spinning and flattened out. Just like if you take a big ball of dough and you spin it in the air like a pizza guy does, it'll flatten out. And so that's how we think our galaxy formed, by a big thing of gas and dust that got pulled in by gravity and flattened out. And of course, everything's falling to the center, so the center has the most stuff. And this thing flattened out and started spinning, but we're still left with this galactic bulge and a galactic center. And we think at the very center of our galaxy is a supermassive black hole that sucks up any material that falls into it. It gets bigger. We can't see the black hole, but we can see stuff going around it real fast, getting sped up and creating a lot of heat. And by all our measurements, it tells us that there is this big black hole in the middle. Now, then there is the galactic plane is referring to this plane right here that the galaxy kind of turns on. There's a, see this kind of red area that goes around everything here? That's called the galactic halo. And it consists of star clusters called globular clusters. And they are very old. We think this galactic halo is the remnants of the giant ball of gas that collapsed to form our galaxy. We think this galactic halo is what's left of it. We'll talk about these open clusters. We'll talk about globular clusters. There's about where our sun is compared to the galactic center. So we call this the galactic bulge, and this area, they don't have it labeled on there. This is the galactic disk. This area that goes around the bulge, the galactic disk. You want to see video footage? Space school. Galaxies are big. So,
I feel really small.
again, the size, our galaxy is about 100,000 light years from one side to another. That means it takes light 100,000 years to go all the way across it. The bulge in the middle is about 16,000 light years thick. And out where we are, it's about 3,000 light years thick. It's a lot thinner where we are. But 3,000 light years, that means it takes light 3,000 years to go from the bottom to the top. Just to give you an example, we're about 2 light seconds from the moon. It takes light about 2 seconds to get from the Earth to the moon. But 3,000 light years to get from the bottom of this to the top of that. So this is a huge expanse of space. Takes, like they said, about 250 million years for our sun to go around once.
So there is a chance, like in the future, we could check out other galaxies as we go around.
On the other side, that's right.
It's just going to take a while.
In just another 125 million years, we'll be all the way on the other side. You can't wait, can you? That'll be great. But since it takes 250 million years to go around once, that means we've only gone around about 25 times in the history of the universe. The universe is about 13.6 billion years old. We don't think the galaxy is quite that old as the universe, but I think the galaxy might be 10 billion years old. So close to as old as the universe. 10 to 12 billion years old. So the next thing the book talks about are the stars that are in the Milky Way. Stars often exist in what we call star systems. A star system is more than a single star. Most stars, when you look up at the stars in the sky, well, first of all, they said an important thing in that video. When you look at the stars in the sky, every star that you see is in our galaxy. You aren't seeing any stars in any other galaxies, and you aren't seeing any other galaxies, because other galaxies are too far away and too faint for you to see with the naked eye. Everything you see in the night sky is in our galaxy. Now, if you had a telescope, you could see other galaxies, but they're too faint to be seen with the naked eye. Stars that you look at in the sky usually are in star systems, which are more than one star orbiting one another. This is a picture of a 4-star system. It's not an actual picture, it's an artist's drawing. these two stars are orbiting one another. We call that a binary. And these two stars are orbiting one another. That's another binary. And in this system, that binary and that binary are orbiting one another, are kind of dancing around like this. That's a 4-star system. So stars usually exist in star systems, more often than not. Our sun is actually a little bit not normal because it exists alone. Our sun isn't going around any other stars. I think it's 49% of stars are alone like our sun. And 51% are in star systems with other stars. Yeah.
What determines whether or not like a star is going to be with it? Like, does that just randomly happen?
When they're born from this huge nebula, like the Horsehead Nebula that we saw, when that collapses, it forms a bunch of stars. If two stars happen to form near one another, they'll go around one another by gravity. If one star just kind of forms by itself and there's nothing very close to it and it's not on any kind of collision course with any other ones, it'll just be alone. So it all has to do with where it forms and what it's near. Now, often you have what's called clusters of stars. A cluster is a whole bunch of stars that are in a group, and they're held together kind of by loose gravity, and they're near one another, but they aren't like orbiting one another. They're just kind of near one another in space. We call that a star cluster. These are two famous clusters. That's called the Jewel Box cluster, and this is called the Pleiades. Sam and I saw the Pleiades last night. This is a cluster of stars in space that sits kind of to the northeast in the sky from here right now, and it's just little. It's about as big as half your fingernail in the sky, and it's just this little bunch of blue dots, and you're like, yeah, what's that? That's what Sam said. He's like, what's that? And I was like, that's the Pleiades. So we're going to talk about that tomorrow. And now he's not here. Come on, Sam. Anyway, we saw this. Now this is through a telescope. With the naked eye, it doesn't look that close. But that's called the Seven Sisters. And every one of these stars is a young blue star. It's blue, meaning it's very big and hot. And it just recently formed. You can even see the dust. See all the dust that's still out there? These stars haven't even cleared the dust out yet. But they're young stars, and they all formed from the same cloud that collapsed. We call that an open cluster. And there are thousands of open clusters in our Milky Way. And this one just happens to be pretty near us, so you can actually see it with the naked eye. If we go out to the beach tomorrow, we can look for these things. I'll show you that one. That one's pretty easy to see. I'm not sure where this one is in the sky. And then there's what's called globular clusters. Globular clusters, let me go back to the picture of our galaxy. Here it is. Here's our galaxy. Globular clusters are these things. They don't usually lie in the plane of our galaxy. They lie in the halo, in this big area that goes around the whole galaxy. And these globular clusters are thousands to millions of stars collected together, and they're all really old stars. All the young stars have blown up, and all you're left with is the old stars, which are all red stars, because red stars live longer. Red stars take tens to hundreds of billions of years to burn out their fuel, whereas blue stars burn out their fuel really quickly, over maybe 10 million, 100 million years. So if you look at one of these globular clusters, you don't see any blue stars there, hardly any. They're mostly red stars, and that means the cluster is really old. we think there's about 150 globular clusters in our Milky Way. So going back to this picture, there's one, there's one, there's one, there's one. There's about 150 of them scattered about. And we think that represents the original big cloud that collapsed into the Milky Way, that these things were there before the gravitational collapse that pulled in everything else. And somehow they were immune to that, which I don't really understand. But they're still out there where the original cloud was. And they didn't fall in like the rest of the galaxy. I've never figured out why that would happen, but anyway, that's what scientists think. You want to see video of star clusters? Star cluster video. Stars, y'all.
Mm-hmm.
Talk about dark matter. Ooh. Scientists measured how fast the galaxy spins.
You hit the...
Whoops! Let's back this up. Do y'all remember from Newton's laws that objects that are near the center spin fast and objects that are further out spin slower? Santana, you with me here?
Yeah.
So, scientists measured how fast things should be spinning based on how heavy our galaxy is. The heavier the galaxy, the faster it should spin. The lighter the galaxy, the slower it would spin. So how do we measure the weight of our galaxy? Well, we count all the stars that we can see. We know about how much a star weighs. And we can figure out kind of the mass that way. We can also figure out the mass of our galaxy by how it affects other galaxies around it. Other galaxies are pulled by our galaxy. There are several galaxies that are going around our galaxy. They talked about in the video how our galaxy is actually eating up some other galaxies, pulling them in, and they are becoming part of our galaxy. So there's different ways to measure the mass of our galaxy, and scientists figured out that our galaxy is way heavier than it should be by what it looks like. Charlie, you up here? Our galaxy should be about 10 times heavier than it is, than it looks. I said that wrong. Our galaxy is actually about 10 times heavier than it looks. And so what they figured out was that there is stuff called dark matter. And we don't know what this dark matter is because we can't see it. That's why they call it dark matter. But every galaxy, including ours, has what's called a dark matter halo around it. It's about this big. And it surrounds our entire galaxy. And they show it here in this picture as this blue area. That light blue area. we know that there's something there, and it makes our galaxy much heavier than it is. This stuff is actually something, it's matter because it has mass. We know that it's there for a lot of reasons. It makes our galaxy spin faster. It attracts other things. And we can see that there's all the other galaxies we look at out there has it too. And we know it's there because of, do y'all remember gravitational lensing? If something goes behind another galaxy, if some far-off galaxies go behind a galaxy, we can see the light of those far-off galaxies gravitationally lensed as the light goes around these galaxies. And we know by the lensing effect that there must be a whole bunch of stuff, not just the galaxy that we can see, but a whole bunch of stuff around it. And we don't know what that stuff is. So they call it dark matter. We know it's not gas or dust or black holes or something like that. It's probably a particle. It's probably made of particles that are so small that we've never discovered them. And that's one of the major mysteries in science. We don't know what dark matter is. And hopefully in y'all's lifetime, hopefully in my lifetime, they'll figure it out. They're working on it right now. The way they're working on it is they take these big super colliders. Have you ever heard of these? The Large Hadron Collider, you ever heard of that? And what it does is this giant machine that they built in Europe, and it spins around particles and uses magnets to get particles going at near the speed of light, spinning around. It's this giant track that's like 40 miles all the way around. And it gets going at near the speed of light. It gets going around this track thousands of times per second. And then they get another particle going in the opposite direction, and they slam them together. And when particles slam together at that high speeds, they blow up, and they ought to create some dark matter when they do it. Because we think dark matter, these little particles that make up dark matter, were something that was created when the universe was very tiny and energetic. I don't know if y'all know, but the Big Bang Theory says that the universe expanded from a small point. So at one point, everything that you see in the universe was in a real small space. And it was real hot, and it was real energetic. And we think all that energy created maybe all these dark matter particles. And this is what quantum physicists are working on, figuring out what this stuff is. It's like one of the there's like 5 major things that we don't understand that we want to understand. And what dark matter is one of them. It's like this amazing mystery that no one knows what it is. You want to see video footage of dark matter?
I don't have a copy.
This will be really cool if they discover what it is. It'll make the news. You'll hear all about it.
60-second adventures in astronomy. Number 8, dark matter. What's the matter with dark matter? Fritz Zwicky was a Swiss astronomer who could probably get you 81 points on a triple word score in Scrabble. In the 1930s, he noticed that galaxies within clusters were zooming around far quicker than their mass would logically dictate. So he figured that there must be some extra mass in there, some sort of dark, invisible matter slurping around the universe. He imaginatively called this dark matter, dark matter. But the problem is trying to prove it, because unlike other dark things, you can see right through this stuff, and this gave Zwicky another idea. According to Einstein's theory of general relativity, the more mass something has, the more it magnifies and distorts objects that you can see through it. So by studying the distortion of distant galaxies, we can calculate that there must be some extra mass between us and them. But because we can't see it, touch it, or weigh it, it's not surprising that we can't figure out exactly what it is. And that's what the matter with dark matter is. It makes up most of the mass in the universe, but when it comes to knowing the details, we're still in the dark.
What was his name?
Fritz Zwicky. Fritz Zwicky was the first guy to talk about dark matter. I don't know if that's in your book. So, read about the Milky Way.